Yeah. Okay. So any questions based on yesterday's session before we move on? Okay, perfect. So yesterday we discussed, right, how H1 and between H1 and H2 communication will happen and how VXLAN header will be added. Now let's move to next, that is okay. So now do you guys know what is Anycast IP address? Any idea why we need Anycast IP address?
Yeah, it's the same. Basically, the IP address configured on multiple leaf switches or depths.
Yeah. Okay. So gateway IP address, right?
Yeah. Yes.
Okay. Okay. Now, so what is the purpose? What will happen? Let's say this is our VTAP, right? VTAP 1 and 2. Basically VTAP pair 1 and VTAP 2 and VTAP 3, right? And we have different IP address configured. So these two are routing VTAPs. VTAP 1, VTAP 2 is also routing VTAP. This is bridging VTAP. Okay. And we have different IP address, gateway IP address configured. So here it's 10.10.10.1, 20.20.21, and here it's 10.2 and 20.2, right? Can anyone tell me what problem we'll see with this? You got the point, right? It's a different gateway address. So here you will have gateway 10.1 and here it might be 20.2, right? Different gateways.
In case we do like a vMotion to a different KSXIOs, then they'll have to change the gateway as well.
Okay, so let's say we move H1 to here, right? H1. And now the gateway was 10.1, right? But the first hop gateway is what? 10.2, right?
To
So we might need to change the gateway, correct? Or it can run through this, but obviously, packet has to forward, even though packet has to go here, first it has to go to the gateway, right? 10.1,
yeah.
and then it will be forwarded here, right? So unnecessary, you will have, traffic trumbuling, correct? Okay, so that is one reason that, we should have same gateway, right?
Yeah.
Means basically same gateway. What else? What is another problem? Let's say here gateway we change to 10.2, right? What else? What else is the problem?
Maybe for the inter-VLAN routing on the same VTEPs, it will have to go to like the same gateway, which may be across the spine or data center.
Okay, so let's say you want to communicate between 10.2 to 20.2, right? Sorry, 20.11, and here it's a 10.10, right? IPH1. So it will come to the gateway. You have made change the gateway to this local one. It will route into VLAN 20 because our destination is 2020, 2011, and then it will forward the packet, right?
Yeah.
So is this a problem?
If this goes down, then it will not have the reachability. So
yes, redundancy, right? Yes. So any of this, let's say this goes down, right? Or this goes down, the host who has gateway as 10.10.10.1 will not have reachability, right, to the gateway. Similarly, who has 10.2 will not have reachability to the gateway, correct? So basically traffic will be black hole. So that is one main reason for Anycast IP. Obviously, the first one also is redundancy, right? You don't have redundancy, correct?
Yep.
Okay. What else? Anything else? What will happen to? Okay, so basically, Yeah, I agreed that, yeah, redundancy is the issue, right? So let's consider that everyone has the same IP address, right? So let me make that change. So all the gateways has same IP address. Okay. Now, do you see any problem when H3 wants to resolve the R for the gateway? What will happen?
Mac, the law are like keep on refreshing the R's because the MAC address of all the VTEPs would be different and they are the same IP.
Yeah. Okay. You are right. So basically, what will happen? Let's say H3 sends out ARP request, right, for the gateway, which is 2020. Let's make this also, right, the one, correct? Original one. Okay. So now let's say H3 sends out ARP request, right, for the gateway. What this VTEP will do, bridging VTEP, it will flood because it's a ARP request, right? It will check the VLAN show VLAN table for VLAN 200, right? And it will check that what are the ports where I have to flood this traffic. So it can be ET1, ET2, ET3, whatever, right? Plus VX1, because this is VXLAN extended, right? So now it understands, it will obviously forward the traffic to the local ports, but it will also understand that it has to forward to VX1 interface, right? So how, on what basis it will decide that I have to forward traffic to VXLAN interface? What are the VTEPs?
VTEP 1 and 2.
Yeah, but what command or what configuration it will check?
Flood list.
Flood list.
Flood list, right? Static flood list. What happened? So flood list, right? 1 minute, let me clear this. Okay, so it has to send the traffic. Why? Okay. So 1 minute, why I'm okay. So it will flood the ARP request to VTEP 1 and VTEP 2, right? Now what will happen?
It will reach both the VTEPs and both of them will be replying to it.
Okay, so both will reply back, right? So this VTEP will reply back that if you want to read to this gateway, what is the MAC associated?
The VMAC.
Yeah, but right now we have not configured VMAC.
Okay.
So let's say MAC B,
the,
right? MAC B here, right? This VTEP will reply back with its own physical MAC. And okay, let's keep this C, right? I think so. This is A only. Sorry, let's keep it A or C, whatever, right? So it will reply back with A, right? And this guy will reply with MAC B. So what will happen here on ARP table on the host?
It will keep on flopping.
It will flap, right? Yes.
Yeah.
So for MAC address of, so ARP table for this IP, gateway IP, initially it was learned through A, MAC A, means ARP was resolved to A, and then it will be B, right? And in case of VARP configuration, we will have gracious ARP continuously generated by all the VTEPs, SVIs, right? So basically it will keep on flapping, right? So what is the resolution? What should we do?
Configure the same VMAC.
Yes. So we have to configure the virtual MAC, right? Which should be same across all the VTEPs. So that's what we should do. Right? So now your problem is solved. When H3 sends out ARP request, both it will get to both the VTEPs, and now they will reply back with virtual MAC, right? right? So now this is resolved through virtual MAC. Both will reply that, hey, if you want to reach me as a gateway, you have to, my MAC is virtual MAC, basically, right? So now, so basically point is, whenever you have VIP, virtual IP address, right, or Anycast IP address, you should have virtual MAC configured. Does that make sense?
Yes.
Okay. Any question on this? Is this clear? Yeah, go
Just
ahead.
one question. So before, sorry, before we configure VMAC, right? So the VTAP one, MAC A and MAC B, that's an MLAT pair, right?
Yeah.
So if the ARP is coming from H3, it will go to both of them, right?
No. Okay. So see, VTAP IP for both of that is what? 1111, right?
Okay.
So
Okay.
here it will check route for 111 where it will have ECMP, and it will check, choose only one path and send out ARP request to any one of them based on ECMP.
I forgot L3.
Yeah.
Okay.
Okay.
Yeah. Thank you.
Clear? Anything else? I just changed MAC here, right? Just to avoid confusion. So we'll make it D. Okay. Yeah. Okay. So is there any question?
Yeah, Vishal. So when before VMAC, once both the VTAP 1 and 2 will reply to VTAP 3. So we'll see the duplicate packets there on S3.
Yeah, because yes, you are right. So basically what we'll see on H3 is VTAP 1 is also replying, VTAP 2 is also replying, right? So you will see multiple packets for on H3. But now the problem, right, where gateway was associated with different MAC, physical MAC, that will not be there, because everyone will say that, hey, to read the gateway, you have to send packet to VM, virtual MAC. But yeah, you will get duplicate many ARP replies from all the VTAPs. So if you have in your network 100 VTAPs, H3 will receive 100 ARP replies, right? Routing VTAPs.
Okay.
But so yeah, we will discuss that, how to resolve that issue.
Sure.
Yeah.
Okay.
But that problem is there right now.
Fine.
Okay. Anything else?
So one more thing that will happen here is like on VTEP 3, when you have the ARP replace coming from VTEP 1 and VTEP 2,
Right.
the VXLAN address table, it will flap between the VMAC entry will flap between the VTEP 1's IP and VTEP 2's IP.
Yes, that we are going to discuss next, that what are the other issues, right, we will face with this. Yeah, you are right. So we will discuss next that one. But apart from that, any other questions? Okay, tell me one thing. See, so here we should have flood list, right? On bridging VTAP, we should have flood list, correct?
Yes.
VXLAN flood VTAP 1.1.1.1 and 2.2.2.2, right? Okay, that also we'll discuss next. I think right now let's keep it as it is. Okay, so coming back to this slide, right? So we have different ways for Anycast IP address, right? So one is VARP, right? So on interface, we configured interface VLAN 10 IP address. This is the physical IP address, and this is the virtual IP address. So 10.100.1.1.101 is physical IP address, and on VTAP2 IP address, physical IP address is different, 102, and virtual IP across all the VTAP will be same, right? 1.1.100.1.1.100. And we also have virtual MAC same across all the VTAPs. Okay. So this is one way we can configure anycast IP address. Obviously VRRP is also another way, but that is active passive. It will not act as active active, right? So if we want to make it active active, we have VARP, right? And another possibility or we can configure is IP address virtual, where we don't have to give physical IP address, right? We can directly give virtual IP address only, right? And virtual MAC, which should be same. So both of these should be same across all the VTAPs. Okay. Any question on this? If you have not understood this.
IP address virtual we configure only with the VXLAN, right?
Yes, that's right. And we will discuss why, right? Why when you are running VXLAN, then only you have to configure IP address virtual.
Okay.
Yeah. Also, one more difference is between these two is IP address virtual does not send the GARP, gracious R packets, right? However, when if you have configured VARP, right, we will send the GARP packet. So if you have configured GARP, VARP, VTAP will send out the gracious R packets, right? But if you have configured IP address virtual, it will not send out the gracious R packets. Okay. Now, can you tell me which one is better, or what is the problem with, VARP configuration?
Wastage of IP addresses.
Yes. So let's say you have 100 VTAPs in your network, right? DC. So out of /24, let's say usable IPs are 254. Out of that 100 will be utilized for your physical IP address and plus one for gateway, right? So basically you will have effectively 150 hosts where you can apply this IP address range, right? IP addresses. So that's the problem with this VARP, right? Yeah, where you will end up utilizing your physical IP addresses from your subnet of hosts, right? Is it clear? Any question? Okay, so if there is no question, then let's move to different variant, right? So we understood, we already discussed how packet flows. Now there are different variants of routing models in VXLAN, right? One is direct routing, another is indirect routing, naked routing, and hybrid, which is direct plus indirect. Or we can also say there is one more is centralized routing. Okay. So let's discuss first what is direct routing. Anybody knows what is direct routing?
All the SVIs should be present in all the VTAPs.
Yes. So direct routing means this, right? All the SVIs are configured on all the VTAPs. So basically what will happen when, let's say, you want to communicate between host 1 to host 2, right? What will happen? Why it is called direct routing? So at the first, go ahead.
First stop it will do the routing from
Yes.
100 to 200.
Yes. So as soon as this H1 comes, for sending packet to H2, it comes here. It will land into VLAN 100. It will check the destination IP as 200.111, and it will do routing here. And from here, it will route from 100 to 200 within here, and then it will bridge the traffic, right, into VLAN 200 to the end host, right? Similarly, when H2 has to reply back, it will first send to the gateway VLAN 200, right? And it will check that destination IP is in VLAN 100. It will route here from 200 to 100, and then bridge the packet directly to H1, right? So basically, that's why it is called direct routing, because you are doing routing at the first hop, right? So that's why this is called VXLAN direct routing. Anyone has any question? Okay, so let's now discuss what is indirect routing, right? Indirect routing means you don't have all the SVIs everywhere on all the VTEPs. Like here, bridging VTEP, right? In your topology, you have bridging VTEP where SVIs are not there. So basically what will happen when H3 wants to send packet to H1, it will forward the packet to the gateway, right, of 2020 to 2020-21. So basically traffic will come here and it has to either of this VTEPs. So let's say it is going here, right? Now it will route from VLAN, it will check the destination IPS 10.10.10.10, which is SVI 10. So it will route traffic from 20 to 10, right? And then send the packet to the H1, right? Is it clear?
Yeah.
So can you tell me what is the problem with this? Okay, so
I think if
yeah.
there is a problem on VTEP2,
Mhm.
all the hosts cannot communicate with each other.
Sorry, host cannot communicate with each other, you mean to say?
I mean, if there is a problem on routing VTEP,
Okay,
so then all the hosts cannot communicate to with the other subnets.
okay. Let's say this routing VTEP is down, right? Right. You mean to say that if any VTEP is down or problem?
Yes, I mean there is a problem on routing VTEP2.
This one, right?
Yeah.
Yeah, but let's say this VTEP goes down, right? Let's say,
Mhm.
or there is a problem, then this gateway will not be advertised. Basically, the packet, right, will be sent to this VTEP, right? And it will route packet from SVI 10 to 20.
Oh, so there is a SWI on VTEP1 as well.
Yes, yes.
Ah.
So we have this two are routing VTEPs and this also has routing VTEP. So this is also here, right? So this is routing VTEP and this is routing VTEP and this is bridging VTEP. But you are right. If we have centralized route VTEP, right? Only one VTEP pair as a routing VTEP, then what you mentioned is right. But the problem here is that, you know, instead of traffic going directly to H1, it might go take a longer path, right? It first might go to this VTEP and then go to this, right? So that's why this is also called indirect routing, right? Is it clear?
Yes.
Okay. Now, what is the reason, right? Why we have to configure some of the VTEPs as bridging VTEP and some as routing VTEP? What can be the reason for it?
Maybe resources on that
Platform.
router.
Yes, right. So it is possible that, right, that customer don't have all the switches which supports routing VTEPs, or even though it supports, see, basically the point is all the routing VTEP need to learn all the ARP addresses, right? Let's say you have 10,000 hosts in the network, then all routing VTEP has to learn ARP for all the 10,000 hosts, right? And it is very much possible if your some VTEPs are bridge 720 XP or low end routers or switches, they don't have that much capability, right? Or say resources. So that's the reason there are possibility that customer might use indirect routing, right? Where some VTEPs are bridging VTEP and some are routing VTEPs. Okay. Okay. So any question?
Hey Vishal, you said the like all the VTEPs need to learn the ARP.
Yeah.
I guess if you don't have the routing VTEP, like if VTEP 3 is not a routing VTEP, but it's still all the VTEPs still need to learn the MACs
Yeah.
like of the hosts that are local to each other, right?
Yes. So if VTEP 3 is only bridging VTEP, obviously it don't have ARP, don't have to learn ARP, or ARP will not be there, but it has to learn the MAC addresses of all the hosts through whom basically it's communicating, right? So H3 is communicating to H1, then H1 MAC should be there. It has to learn. Yeah.
Got it. Thanks.
Yeah. Okay. Anything else? Okay. So now third variant is centralized routing, right? What does that mean is now you have only one VTEP, which is routing VTEP. All other VTEPs are bridging VTEP. So here, this is also bridging VTEP, right? So this is also bridging VTEP. This is also bridging VTEP. In the network, you have only one routing VTEP. So what will happen if H1 wants to communicate to H3? How traffic will flow? It will first send the packet to the gateway, right, of this 10.10.10.1, which is obviously only on this VTEP. And then it will route the traffic from 10 to 20, and then it will forward it to H3, right? And the problem with this is, as Okwan mentioned, that if this VTEP fails or if this VTEP malfunctions, then your host to host communication between different VLAN, inter VLAN is affected, right? It will be blackout. We can have MLAC pair, right? Just to make sure if one VTEP fails, the other VTEP will take care of it. But if in case both VTEP fails or there is a bug on both the switches or any issue with this DC, we'll lose connectivity between different VLANs, inter VLAN. Is it clear?
Yep.
Yes, Vishal.
Okay. And the last one is naked routing. So naked routing is nothing but our normal routing, right? Where, let's say you from this host, you are accessing google.com, right? So whatever traffic comes to, it will come to the spine and then straightforward, it will be sent to H2. There is no VXLAN encapsulation. So that is called naked routing. Means our normal routing, basically. No VXLAN encapsulation, right? So that is called naked routing. So yeah, we have 4 different variants: direct routing, indirect routing, naked, and hybrid, or we can also call it centralized routing, right? So these are 4 different variants. Any question, or if anyone has not understood any point? Okay, so now let's go to the problems, right? Which Rohit has already mentioned, right? So let's again discuss this. See, H3 wants to communicate to the gateway, right? H3 sends out app request for the gateway. It will be flooded to both the VTAPs. Both the VTAP will receive this app request, right? And they have to reply back, right? So let's say VTAP will reply back with app request. Can you tell me what will be the MAC and VXLAN address table update?
MAC will be the VMAC.
And
That
VLAN is 200,
okay,
right?
200. Yeah.
MAC is VM. Let's say VM, right? Keep it VM. And interface?
VX1.
VX1. What is this VXLAN address table? VLAN 200, right? VM, correct? And what will be the VTAP IP? We are receiving a reply from VTAP 1.
111.
1111, right? Because this is the VTEP IP.
Yeah.
Okay. Now this ARP request has also gone to VTEP2. So VTEP2 will also reply back because it also has SVI, right?
Mm-hmm.
So what will happen? It will reply back again that VLAN 200, right? I have VM on VX1. So this entry will remain same.
VXLAN address table will change now with 222.
2222, right? So basically what we will see is, right, this is changing, right?
Mm-hmm.
Virtual MAC initially was associated behind this VTEP 1111, but after some time when ARP reply received from this VTEP2, it will change to 2222, right? And think about warp. You have configured warp where all the VTEPs are continuously sending ARP gracious ARP. What will happen? So basically what they are sending, hey, 10.10.10.1 is on V associated with VM virtual MAC. It will also send V 2020-21 is associated with VM, right? So this, all the VTEPs are continuously sending gracious ARP. What does that mean is on this bridging VTEP, you are keep on changing this, right? For all the VLANs. So even for VLAN 100, you will keep on changing VM to 1111 or 2222, right? So if you, let's say you have 100 VLANs, your this entry for all the VLANs will keep on changing because gracious ARP will continuously send by all the VTEPs. And if there are 50 VTEPs, you can understand what will happen, right?
Yes.
Between all this, it will keep on changing, which can, make CPU high on this particular VTEP and can cause, and if CPU is high or particular VXLAN agent is running high, it might miss some learning and all that stuff, right? So basically it can create a lot of issues, right? So what is the solution? So you understood the problem, right? That this will keep on flapping, right? So what is the solution?
Virtual IP.
Yeah, we have virtual
VTEP.
IP configured. We have virtual IP and VM configured.
Virtual VTEP.
Yes, so we have to configure VTEP, right? So basically one rule is very clear and we will use or discuss about this rule again and again. If you have virtual MAC and virtual IP, everything should be virtual. Then only this will work, right? Otherwise it will create a problem. So initially, if you remember when we discussed today, if we have virtual IP but physical MAC, right? Then we observed that issue is that at end host, that MAC is flapping, right? With virtual IP, correct? So that's why we have to decide that to change this virtual IP to virtual MAC. So basically, if we have virtual IP, we should have virtual MAC. Now we have both virtual, but now as we see here, we also need to have virtual VTEP IP, right? Otherwise VTEP will flap, correct? So basically one thumb rule is if you have MAC virtual or IP virtual, everything should be virtual. So VTEP IP, when you encapsulate the packet, your source IP, outer source IP should be virtual VTEP IP, not the physical VTEP IP. Is it clear? So basically when this VTEP1 will send out ARP reply, right? When VTEP1 will send out ARP reply, the outer destination source IP will be 5.5.5.5. Okay, outer source IP. Similarly, here also outer source IP, when it reply back will be 5.5.5.5, right? ARP reply. So when this guy receives the packet, it will now point it to 5.5.5.5 or even ARP replies, right? Because it will always be 5.5.5.5. Is it clear?
Yeah.
Any question? I might be going fast today because we want to complete today all the VXLAN concept, but feel free to ask me or stop me. Okay. If you have any question at any point of time. Is it clear? Any question? Why we need VTAP IP?
All good.
Yeah, makes sense.
Yes, clear.
Okay, perfect. So now let's move to next issue. So this is the one of the issue if we don't have VTAP IP, right? There is another one, which is this one. So what? So basically, let's say H1, right? H1 host is sending out ping, basically ping for its gateway. So basically H1 is wants to send packet to any other VTAP, let's say 200, right? This 200.112. So it will send out ARP request to the gateway, right? So it has sent the ARP request to the gateway, right? Now this is SVI 100 is configured here. So this will reply back ARP reply. So basically what you will have in ARP is that to reach the gateway, right? What is that gateway IP is this 100.1.1.100. You have virtual MAC, right? Associated. So this is your ARP reply, ARP entry. Now, as we discussed, right, ARP request, because this is a bump traffic flood ARP request. So what it will do is it will also flood this to all the other ports. So it will also flood to other VTAPs, right? This, both the VTAPs. Let's assume this is also routing VTAP. Okay. What will happen? Both will reply back, ARP reply with its physical MAC. They will reply back with physical MAC. Okay. And what it will cause here at end host is it will flap your gateway ARP between virtual MAC and physical MAC of your other VTAPs, C and B. So basically at end host, your entry will flap, right? So this is one another problem, and that's the reason where we need VTAP IP, right? I'll explain you how we are going to resolve by using VTAP IP. Okay, this issue. Is it clear?
Yeah.
Yeah. Another issue, what I believe one of you have pointed out, right, is I think Ajay has pointed out that this ARP request, obviously this will get the ARP reply, but unnecessary all the other also will reply back, right? If there are 50 VTAPs, all will send out replies, right? So unnecessary you will have in your network so many ARP replies, right? ARP packets flooded, or not flooded, ARP reply will receive, right? And if there are 1,000 or 10,000 hosts, you might see a lot of ARP replies into the network, right? So these are the two more issues, right? What we see in this type of scenario where VTAP is not configured. Okay. Now, how we'll resolve this by using configuring VTAP. So let's say we have configured VTAP, right? Now what will happen is, let's say this guy has sent out ARP request. Okay. What is the flood list? 222, 333 and 555, right? We also have to add in flood list 5555, which is the virtual VTAP IP. Okay. So now H1 has sent out ARP request. Obviously this guy will reply back. Okay. Now this will also flood this traffic to all the VTAPs, right? So it will send out the ARP request to 222. It will send out to 333. Will it send to 555?
Yeah.
No, because
Not.
it's on.
Its own IP address, right? It is configured everywhere, right? This VTAP is configured on all routing VTAP. So it will not send to 555. It will only send to 222 and 333. Is it correct?
Then why are we configuring it in the thread list?
Sorry.
Why are we configuring 555 in the thread list?
Why we configure, you mean to say?
In the thread list, VTEP. If it
No,
is
so
not
your
good.
question is why we configure or we will configure or not, means?
Yeah, we'll configure it or not in the thread list.
Yes. So basically in routing VTEP, if we don't configure, then also it's fine. But I will explain why, as a consistency, why we configure it. Why should we?
Okay.
There is no harm in configuring, basically.
Okay.
So even though you have configured, it's not going to send it to 555 because it has its own IP, right?
Yes.
So it will not send that packet. So basically it will send the ARP request to 222 and 333, considering this is also routing VTEP. And even though it's not, it will send it. This guy will ignore. That's a different story. But here right now, let's say it's routing VTEP. Okay. So now this guy is sending ARP request, right? Now what will happen? We have one rule to avoid duplicate ARP packets and that host flap, right? The issue what we have seen. However, in new, that issue is also not there. It is basically we have resolved. But basically we have one rule to avoid duplicate ARP replies, because all VTEP end up sending ARP replies, right? So rule is any VTEP who receives the ARP request for the gateway IP, right? Gateway IP, it will only reply back to that ARP request if that ARP request is received from the source VTEP, destination VTEP IPS 5555. Destination, outer destination VTEP IP is 5555. So let's see here. See, ARP request, this guy is sending to 2222. So what will be the outer destination IP? 2222. Right? Sorry, here it's 3333. Right? Outer destination IP. And here it will receive with outer destination IP 2222. Is it clear?
Yeah.
Now, if this VTEP receives the ARP request with outer destination IP 2222, will it reply as per this rule? Rule is, if outer destination IP is 555, then only I will reply. VTEP will reply. Otherwise not. So VTEP 2 will reply back ARP request.
No.
No, right? Because it's not, this rule is not met. Same for 333, right? It will not reply back. So now we are solving both of this problem, right? Where host flap, because now other VTEPs will not send that ARP reply, and unnecessary ARP reply across the network, right? All the VTEPs. That also we are eliminating by this rule. Have you agreed? Are you guys agree? Any question if you have not understood?
Vishal, I have one question.
Okay. See, yeah, there are a lot of concepts, so it might you might feel that it's overwhelming, but yeah. Okay, so this is the three different reasons, right? Why we need VTEP IP, right? So first is
Vishal,
yeah,
am I audible?
yeah.
Yeah, I have one question actually. Can you open that diagram? Okay, so if the destination IP is not 555, so VTEP 2 will not respond back, right? Correct? It will discard the packet. The third rule which we are talking about.
Okay, so let's say yes, you are right. So let's say this ARP request is forwarded, right, to 222. So it will forward to 222 and 333, right?
Correct.
So it will forward to 222 and 333. Outer destination IP will be 333
222.
222. And our rule says that if that is the case, right, we will if ARP request is received by routing VTAP, it will only reply if outer destination IP is with 555.
Okay. Let's say we have only one bridging host connected there in
Okay.
VTAP 2.
Okay.
So
Yes. No. So see, host is never bridging, right? Host is host. VTAP is routing or bridging.
yeah. So when let's say H1 is 10, 10, 10, 10 is need to talk with 10, 10, 10, 20, right? Another host there in the inside the VTAP 2 S3.
Okay. Okay. Let's take that 1 minute. Let me clear and open this one, right? This one what we were discussing. Okay. So now your point is there is one host, right?
Yeah, S3.
H4. H3 is already there. Let's take 4. And IP is
100, 11,
100,
115.
115. Okay. Yeah, go ahead.
Okay, so now H1 wants to talk H4. So in the flood list, it will flood with 222, destination IP 222, right?
Excuse me. So
222 and 555 as well, right?
yeah. So basically H1 receives the ARP request, sends the ARP request for this host, end host, right?
Correct. Yeah.
Now VTAP will receive this, but obviously this IP is not on its own, right? So it will not reply back, right?
Correct.
And
Right.
it will be flooded to 222 and 333. 555 is its own IP. It will not flood, right? So it will send that packet to 222 and 333,
Right.
right? Yeah.
Yeah. So now VTAP 2 will see destination IP is not 555, right? So it will not reply
Okay.
back.
No. So what will happen here? See, it receives the ARP request, right?
Correct.
Now it will check whether the destination IP for which ARP request has come, is it for gateway IP?
Okay. Okay. So
It's
this
not
rule
gateway
is
IP, right?
especially for the gateway IP, correct?
Yes. So if it is gateway IP and 555, don't. Okay. So when VTAP 2 has to reply back, when it's ARP request is for its own IP, right?
Oh.
But otherwise it don't have to reply back.
Yes.
Right. And that's why this rule comes into place when it has to reply back.
Okay. Got it.
Got it. So basically what it will do is it will decapsulate the packet. It will check destination IP is not my IP. I don't have to reply back, right? So this rule is will not come into place. It will decapsulate the packet, and because it's ARP request, it will flood out on that VLAN.
Okay.
And this H4 will receive that and it will reply back. Okay.
Okay. Got it.
Clear. But yeah, good that you asked this question, for clarification. Okay, now there is another issue. Okay, so this is clear, right? Now tell me one thing. If H3 wants to communicate with H1, right? What will happen? H3 will send out ARP request, right? Let's say flood list is 111 and 222, right? Both VTAPs. You missed to configure 555, right? You have not configured, you missed it somehow. What will happen?
It will never receive a reply.
Yeah, so IAP request will go here and here for the gateway IP, right? Both will check, hey, the ARP request is for my gateway IP, and it wants to reply back, but it checks that, hey, this outer destination IP is not 555, so it will not reply back. Same for this guy. So what will happen? H3 will never get the ARP reply from any of the VTAPs, right? So that's why it is very important that you configure virtual VTAP IP in flood list of bridging VTAP. You should never miss this. Make sense?
Yeah.
And that's why when Akshit, you ask, right, 555 is needed here on routing VTAP? No. but just to make that it's everywhere, it's same configuration, it's better that we add everything on all the VTAPs.
Yeah.
For consistency, because otherwise you might miss, you might not remember which one is bridging and which one is routing, and you might miss configuring this, right?
Yeah.
So yeah, this is one basic when you troubleshoot, VXLAN, this can be one issue if there is a mixed topology, right? Asymmetric or centralized bridging VTAP. Is it clear?
Yep.
Okay. There is one more. Okay, so we have, as we discussed, right, this virtual MAC is configured on all the VTAPs, right? Right, we need to have virtual MAC configured, right? Now what happens, let's say this virtual MAC is also configured on bridging VTAP. Okay, let's say this guy is sending, in case of IP address virtual, this guy is sending out ARP request, right? For this host, it wants to, H1 wants to communicate to H3. So what will happen? This will send packet to gateway. It will route from SVI 100 to 200, and then 200 it will send out ARP request for this IP address, right? And source IP will be virtual IP, right? And source MAC will be virtual MAC, inner source IP and MAC, right? When H3 reply back, right? If you have this virtual MAC configured here on this, actually this reply should go to this VTAP, right? Then only it will be able to resolve ARP for this host, right? But when H3 reply back and this VTAP already has virtual MAC configured over it, what it will do? It will consume that this packet is for me, and it will consume this packet. It will never forward it to this guy, right? Is it clear?
Yeah.
So that's the reason. Another thing you need to make sure is you should never configure virtual MAC on bridging VTAP. Okay, so basically there are 2 points. One is you have to make sure you have flood list, this 5555 in flood list configured on bridging VTAP, and you should never configure virtual MAC on bridging VTAP. So this is another common issue what we see when we have this mixed topology. Okay, is this clear? Any question? Okay, and one more point, you should also not, so you should have this flood list configured, right, on bridging VTAP. That is must. You should not have virtual MAC configured on bridging VTAP. That's must. Another is you should never configure VTAP here on bridging VTAP. Loopback IP address, secondary loopback IP, right? So interface loopback 0, right? You will have VTAP IPs for primary IP as 3333. You should not configure secondary IP as 5555. Why?
Because request will never go out from that VTAP.
Yes, for 555, right?
Correct.
So even though you have this configured, what you will do, right? When H3 wants to communicate, get ARP reply from for the gateway, it comes here, it sends to 111. 111 will not reply because the outer destination IP is not 5555. It will not reply. It goes to 222. It will also not reply. It should have to send. It will also has to send to 555 because its own IP it will not send out, and it will not send out. That means you will never going to receive the reply, right? So you also have to make sure that this should not be configured. So these are the 3 rules for bridging VTAP in mixed topology. Okay, if this is not configured, what it will do? It will send out our request to 555 as well. Based on hashing, it might end up here or here going. Let's say it goes here. It will check the ARP request. It is for SVI IP address, which is its own. It can reply back. It will check the destination outer IP, which is 555, which also passes the rule that I can reply back, and it will reply back with virtual MAC as the gateway IP, right? Is it clear?
Yes, I think we probably need to watch the recording again.
Yeah, there are a lot of stuff. Uh, sorry for that. We can't, means take more time on this. But yeah, definitely you guys should know this before we move on to EVPN. So just go through recording again. Okay. So yeah, we have discussed all this, right? Mac flap and all this different issues, right? And why we need virtual VTAP IP. So you can also refer to this PPTs, which I have already placed into that document. And VTAP requirement. So this is how we will configure virtual VTAP IP address as a secondary IP address, right? And this is bridging VTAP, where we will not configure virtual VTAP IP, secondary IP, right? And also floodlights, we will make sure 555 is configured. And if you see another difference, VTAP 1, which is routing VTAP, we have VMAC configured, virtual MAC configured, which is not configured here, right? So whatever three things we discuss, it is in this configuration you can see. One is virtual MAC should not be configured on bridging VTAP. It should be there on routing VTAP, right? 555 VTAP IP should be present on routing VTAP, but not on bridging VTAP. And flood list 555 should be present on bridging VTAP. It's fine if it is not there on routing VTAP, but if it is there, then also it does not make any problem, cause any problem. Okay. Okay. Shall we extend it to more 5-10 more minutes so that we can complete this? Is it fine, everyone?
Yeah.
Yeah.
Okay. Okay. So let's extend now. So yeah, as we discussed, right, we have a virtual router command, IP virtual router, basically warp, right? So this is how we will configure warp, right? A physical IP address, which is two different physical IP addresses on both the VTAPs, right? And then virtual IP address, which is same across all the VTAPs, and virtual MAC, which is same. Okay. Now, this is the packet format for ARP reply and ARP request, right? So let's say this, let's say, this VTAP wants to communicate with this host. Okay. What will happen? It will send out ARP request. Now it will send out ARP request with its own physical IP. This is the physical IP. Okay. And physical MAC. Let's say A. Okay. And this is B. So it will send out ARP request with physical IP and physical MAC, right? This gets the ARP request. Now, because this is port channel, right? It might send out ARP reply to this guy. But because destination MAC is an IP is physical, what this will do, it will forward that ARP request to this guy, and ARP will be resolved on this. Is it clear? Any question?
Yeah, good.
Mr. Can you please repeat this? I didn't.
Yeah. Okay. So let's say, there is one host, right? In another subnet, let's say 20, VLAN 20, right? 0, 0, 10. Okay. It wants to communicate, and this is routing VTAP, which has both the SVIs. So it wants to communicate to this host. What will happen? It will send out the packet, ICMP packet. It will be routed from 20 VLAN to 10 VLAN, 20 to 10, right? Now it will check the ARP on this routing VTAP. It will check the host IP ARP, right? It is not there. ARP is not resolved here. So it has to send out ARP request, right? So when it is sending out ARP request in this warp, right? Warp, what it will send, what will be the packet? The source MAC, right? ARP request source MAC will be physical MAC, which is A, and source IP, sender IP, not source IP, but sender IP is physical IP, which is 10.0.0.3. So this is how we have designed. So when you have configured warp, right, our ARP request will be sent on physical MAC and physical IP. So this guy receives the ARP request. It has to reply back. So what will be the destination MAC? It will be A, right? Reverse of what it has received. And destination IP or target IP 10.0.0.3, right? So when this packet comes here on this switch, let's say it might go directly here or it might send here. It received on this another VTAP where it will check the destination MAC is A, which is learned through peer link, MLAC peer, and it will send it here. So basically whatever ARP request you have sent, it is received back and you will update your ARP. Does this make sense?
Yes, Vishal, makes sense.
Yeah. So so that's why this is what we use, right? So this is our warp config. And this is what I was talking about ARP request, right? So ARP request, Ethernet source MAC is switch 1 MAC, physical MAC, which we discuss as A, right? And physical IP, right? Which is 10.0.0.2 or 10.0.0.3, depends on which VTAP is sending. But physical IP and physical MAC into ARP, right? Is it clear? ARP request. Any question on this? Okay.
Hey, Vishal, I'm
Yeah.
a bit lost to the last this scenario. Are you able to explain that again?
Yeah. Let's go back. Okay. So this is a small topology. Let's add one more host here, right? Host 2 and IP address is 20.0.0.50. Okay. This is routing VTAP. This both are routing VTAP pair. Okay. SVIs are there for VLAN 10, which is this, and 20. Okay. This wants to communicate with this host. So it will send out ICMP packet. ARP is resolved to the gateway. It sends the packet to VLAN 20 gateway. It checks the destination IP 10.0.0.50 directly connected to VLAN 10. It will route the packet into VLAN 10, right? Now it has to send the packet to this host IP. What it has to do, it has to know the MAC address to send the packet, right? So what it will send out? It will send out ARP request, right? To know the MAC address of this host. Now, so we are talking about when it has to, VTAP has to send out ARP request to the host, what format it should use, right? What should be the source MAC? So for VARP, source MAC should be its physical MAC. Let's say here it is A and this is B, physical MAC, right? So it should use physical MAC as a source MAC. And sender IP also it should use physical IP. Why? Because as a rule of thumb, if you have MAC is physical, you should use physical IP as well. Both should be in sync. If your MAC is virtual MAC, you should use virtual IP, VIP. Okay, so that always should match. So because you are sending physical MAC, right? You are in VARP. You will also sender IP also will be physical IP, which is in this case 10.0.0.3, not the 10.0.0.1. Okay. So you are sending with 10.0.0.3 ARP request. Okay. What will happen? This host receives the app request. It checks that the target IP is my IP, right? It has to reply back. So what it will do, it will reply back. What is the destination MAC? Which was the source MAC, right? It has received with source MAC as A. So destination MAC will be A, right? And then it will also fill the sender IP, target IP, uh, source MAC, which will be this MAC. And it, let's say this is port channel, right? Dual home. So it might send this app reply on this link. Then there is no problem. It will be received by this app reply who has originated app request, and it will update the app table for this host. But let's say this packet is forwarded to this switch, right? VTAP B. Now VTAP B will receive the app reply with destination MAC as A. Does this MAC A resides on this VTAP? No, right? So what it will check in its MAC table, how to send packet to MAC A, and it will understand that it's a my through my peer link, right? So it will send the ARP reply, forward ARP reply to this guy, and eventually this guy will receive the ARP reply for request it has sent, and it will update the ARP table. Is it clear? Any question?
Yeah, all clear. Thanks.
Okay. So basically point here is the with what type of format we should use, right? So this is what we should use for VARP, ARP request. Okay. Now let's talk about ARP reply or gracious ARP, right? What should we use? Let's say this host wants to communicate to any other host, and it wants to resolve the MAC for the gateway, right? Gateway MAC address, this gateway MAC. It will send out ARP request. It might send out, this is port channel, it might send out here or here. Let's say it is sending out here. Okay. This guy received the ARP request for a gateway IP, which is here, SVI is here. It has to reply back, right? ARP request for the gateway. Can you tell me what should be the source MAC or the MAC address of that reply gateway? Reply MAC, source MAC, ARP reply.
The VMAC.
Sorry.
The VMAC.
VMAC, right? Why?
Because the request is for the virtual IP.
Yes, so the request is for virtual IP, right? So we should reply back with virtual MAC app reply, right? Another reason is, let's say you reply with physical MAC, what will happen? You get the update this ARP for give virtual IP with physical MAC, which is A. Now, sometime later, if this app request goes here, this guy will reply back it's with its own physical MAC, which is B, right? Or anyway, VARP is continuously sending ARP. So if they are sending ARP or ARP reply with its own physical MAC, B and A, this will continue to flap, right? So that's the reason whenever you send out ARP reply, VTAP send out ARP reply, it will reply back with virtual MAC. Reason is to avoid MAC flap on ARP on the host. And also because you have requested, host has requested a gateway, which is virtual IP. So your MAC also should be virtual in reply. Does this make sense?
Yeah.
Okay. So that's the reason we have this as a packet format for ARP reply or gracious ARP from VTAP when VTAP reply back, right? ARP routing VTAP. So what is the source MAC? It's virtual MAC, right? Because even a host has requested MAC for the virtual IP, right? Virtual IP. He wants to know, hey, what is the MAC for this virtual IP? So you will reply back with virtual MAC, and obviously sender outer Ethernet source MAC is virtual, and obviously inner also it will be sender hardware address when you reply back, right? Is virtual. So this is for warp, where when VTAP requests to host ARP request, sends out ARP request to the host, it sends with physical MAC and physical IP, right? We discuss why it's physical, because otherwise, packet might not reach to that of VTAP who has originated, right? If it is virtual and it lands here, this will consume, because this also has virtual MAC, right? So ARP requests are always physical, and ARP reply or gracious ARP is always virtual. Any question? Okay. So these are the rule, right? Multiple rule which we already discussed. So one is, if Ethernet source MAC address is physical, right? Source MAC address is physical. Outer source IP will be VTAP IP of VXLAN loopback address. So basically, it wants to and another is, if Ethernet source MAC of original frame is virtual, then outer VI source IP will be VTAP IP, right? So basically, what is saying is, let's say physical. Okay, let's say this is sending ARP request to host 3, right? Let's take the other one. Let's say this is sending out ARP request to host 3, right? Packet H1 to H3 communication, it sends out ARP request. Now, as we learn, for warp, ARP request will be physical MAC, right? It will be sent on physical MAC, source MAC. Source MAC is physical MAC, which is A. Okay. And IP, sender IP also will be physical IP, right? Physical IP of the SVI. Now, when you are encapsulating this, right, what should be your outer source IP? Outer source IP. What should be there? Physical VTAP IP or virtual VTAP IP?
Physical.
It should be physical VTAP IP, right? 1.1.1.1. Why?
Because it might won't get reply if it is virtual then.
Yes. So it should be physical, because one is rule is, if physical MAC source MAC is physical, then this also should be physical. Why? Because if you have sent it by 5555, what would have happened? ARP request received here, this guy will reply back, right? Now 555, it will send it here. Now 555 is here also, right? This guy also has 555, right? So this request reply might land it here, and this guy will consume. So whoever has initiated ARP request might not get ARP reply back, right? And this traffic will be blackout. So that's why, if your MAC is physical, your VTAP IP also, outer source IP also should be physical. Is it clear? Is it clear?
Yeah.
Okay. And another, now let's say H3 sends out ARP request, right? And this guy has to send out ARP reply, right? It landed here, let's say, because 555, came here. Now it will reply back with, what is the source MAC? Virtual MAC, right? Because request is for virtual IP, SVIP, right? So it will just reply back with virtual MAC. This. What will be the source, outer source IP? VTAP IP. 111 or 555 with reply. If your sender IP or source MAC is virtual MAC, outer IP also should be virtual. That means VTAP IP 5555, right? And not 1111. Because if you send out with 1111, what can happen? Here again, you will see the VXLAN address table flap, right? For virtual MAC, you are learning through 1111, and there is a gracious ARP also coming from 222. So you will see this flap, right? Which we discussed. So that's why whenever your sender MAC is VMAC, source MAC is virtual MAC, your outer VTAP IP also should be virtual, not physical VTAP. Okay. Any questions? Okay, I think let's stop here because it's already too much. Maybe there are few points which we want to discuss, but we'll discuss in next Tuesday. And yeah, please go through this recording and we can discuss if you have any questions around this today, because we discussed a lot of points.
Yeah.
Okay. Okay, so any question before we wrap up for today?
So now, Vishal, when you get on a call with is this like the first few minutes you should be discussing what's the topology, which one is routing, which one is VTAP, is it VAP, is it address virtual, is it all those kind of things, or will the customer just want straight for you to go into other things? Or because like if you don't know all these things, all these scenarios come into play and you don't know.
Yeah, so actually, as far as troubleshooting is concerned, yeah, we need to understand, right, whether it's a direct routing or indirect routing model, right? If there is all routing VTAPs or there is bridging VTAP. And in case there is a bridging VTAP, then it's basically first thing we can check is the points we discuss, right, for bridging VTAP. That flood list should be available, flood list for VTAP IP should be there. Secondary IP of VTAP should not be configured. Virtual MAC should not be configured. So this things it's better if we know, right, what type of topology it is, and we can check and concentrate on that, depending again on problem. If it's saying traffic loss, right, complete traffic loss, that points that, hey, there is some misconfig, right?
Mhm.
Yeah. So yeah, basically, whenever we go on a troubleshooting, the best thing is to first understand, right, what type of implementation or design. It's a direct routing, indirect routing, right, mix or centralized. And now we have multi-STA, and there are a lot of stuff which is going to come, and VXLAN config sanity is also their command. So that helps us to find out some of these things, and multi-STA will help at large extent, right? So it will be easy for us to find out if this type of discrepancy are there in configuration. But otherwise, we need to go and manually check, right, on all the VTAPs.
Okay.
Okay. Okay, guys. So yeah, let's discuss again next Tuesday, and feel free to go through this recording or ping any of us, right, if you have any question, doubts.
Right. Thank you.